stuff I do. And it's a wood router, right? So it's got a high speed, it's actually a Harbor Freight little trim router on it with a little carbide bit. And I do all strictly flat stuff. I have the capability, with different software to do some 3D things, but kind of like, engravings and stuff like that, but I don't get into any of that,
So usually by subtraction, he goes by addition.
Yeah, see, so totally opposite ways of doing it.
Yeah.
So, and there's no sawdust when he does it, so it's just a smell. So we're going to see that. So I'm going to start out by showing you my whole tool path, so to speak, designing a part in CAD, putting it into the CAM program where you're going to define what your tool does. That program then creates the G code, which then finally I take downstairs on my flash drive to my machine, plug it into my Ubuntu box, and then actually cut the part out. So it's kind of a three-step process. And it'll be similar for Adam, but you'll see differences in how we do these things. Right? So first off, what I use is you can use any CAD you want. If you like AutoCAD, if you like TurboCAD, you like whatever CAD, The only reason why I picked this one, this thing called ViaCAD, is that one, it's inexpensive. It's only $40, okay, which is inexpensive as far as CAD goes. And it's kind of a mixture between CAD and drafting, right? So it doesn't have all the full-blown features and stuff that AutoCAD would have, things that I would never use. So you'll see here, it does some things like when I'm drawing circles and things, it gives me guides and stuff. So it's more of a drafting type program. It's still CAD, but a drafting type program. So once that's drawn up in the CAD, it gets exported as a DXF, right? We're all familiar with that. It's a drawing exchange format, or it stands for something. Anyway, it's a standardized format that the CAM program will then use. Then I'll define all my tool paths. I'll say maybe for this cut, we're going to use a tool that's 1/4 inch wide. And this cut, we're going to use one that's 1/8 of an inch wide. And go this deep and go this fast, tell it the speeds and the depths and all that kind of stuff. So we're going to see that in the CAM program. The final result of that then will be a G-code file, which is just text, plain text, which I would then, like I said, take downstairs to my machine, but I didn't bring mine, because mine's a little bit bigger, bulkier, power supply. It's not as near as portable as Adam's is. So for that, we're just going to use our imagination. I'll show you a couple screenshots and stuff, for that final step. But if you're interested, you can look on YouTube and stuff. You can see videos of CNC machines, and pretty much get an idea of what's happening. So we'll start out by looking at that ViaCAD. And bear with me, I got the wrong mouse and a piece of paper for a mouse pad here. So in ViaCAD, this mouse will even work. There we go. Hang on. So there's a new document here. And I think I'm missing part of my. I am. I should have tested this. Hang on, give me a second. My screen resolution is wrong. Let me come over here. Plus, this is Vista, so it's awesome. Where's my resolution at? Let's see, mouse points thing on display. You can bump that down a little bit to a smaller. Oh, there we go. Oh, so it's only here by 600. Let's see if we can go. See if that'll work. If that works, I don't know if this projector supports.
It's all right. Let's see if I
One more. I think that's going to work. Just apply that. Back here. Huh. I do not know why I don't see my tools there. So let's open up an existing one.
Looks like your tools are on the left hand side.
Are they hidden?
Of your main screen, like you just drag them over. You see that on your main screen?
Oh, there they are. Oh, got it. Nice. Using multiple monitors here. There we go. Jay to the rescue. Okay, so main screen. This point right here is very important. It's called the origin point. The only reason it's important to us now is that on your CNC machine, there's a point defined as the origin. So on my machine, it's a bottom left-hand corner. If I was to draw something to the left or to the bottom of that origin point, my CNC machine would want to come over here and start cutting it out, right? And that's not going to work. So I always have to make sure I stay within these limits. So what I normally do is turn on some things called construction lines, both horizontal and vertical. That kind of lets me know I need to stay in this quadrant up here. So if I'm drawing something, or maybe I draw something that's bigger but then shift it over, I got to be like about 1/8 of an inch inside of these lines. Otherwise my machine, for safety reasons, it'll say you're attempting to move the tool beyond the limits and it'll just stop. Okay? So we've got that quadrant built there. So let's move this over a little bit. So let's just do like a simple base, right? So I'm going to pick a circle that's defined by a center and a radius. I'm going to come here and just draw it out. Now what's nice about this program is I can say my diameter is 2.877 inches, or I could put in 6 1/4. See, and it'll change it to 6.25. Or I could put in 100 millimeters, and it'll convert it to inches instantly. So where that comes in handy is if you're measuring out a part, or you're looking at, like maybe somebody's already measured something out online, you're looking at the dimensions, like it says a servo is 30 millimeters or something. Well, I can just type in 30 millimeters, it'll convert it to inches for me. Because you have to decide if you're going to use millimeters or inches the whole way through your path, so to speak. You don't want to draw it up in inches and then convert it to millimeters in your CAM program and then try to cut it out with your CNC machine back in inches again. It confuses things. You want to keep everything the same. So whether you use metric or English, it doesn't matter, just use the same thing all the way through. And nicely enough, the little $20 calipers you get from Harbor Freight or anywhere can switch back and forth between millimeters and inches very easily. And these are indispensable as far as when you're doing stuff like this. If you're going to if you're going to look at a servo and then measure the width and the depth and all that kind of stuff, great. So you definitely need to get an inexpensive caliper to use for that. So all right, so we got our circle. If that's too big, let's just make it 5 inches. Okay. I'm going to zoom a little bit there. So we have a circle. So we'll create something. We'll create something like this. Okay. So a circle with holes cut for a Tamiya gearbox. It's a real common gearbox that a lot of us use. I don't know if I see one. There we go. So there's your Tamiya dual motor gearbox, right? You can get them at Mark Twain, get them at Gateway Electronics. They're 10 or 11 bucks or so. They're not the best motors. They're real noisy. They're real inefficient, but they work. Okay. So you've got forward and reverse control over 2 motors independently. So it's nice for a little round platform. So if we have something like this, and we got to get obviously the measurements correct for the Tamiya gearbox, and also the mounting holes, and then also the holes to mount the other deck, if that's what you were doing. So similar to this robot, has an upper deck with some supports. So we got to measure all that out. So that actually will go very quickly. Because I have made a thing called a common parts folder where I've already drawn out the Tamiya gearbox, so I can just select it, I can copy it. Oops. Hang on. I told you this wasn't my regular mouse. We'll do it this way. Okay, so I copied that drawing back to my first one. Now I'm just going to paste it in, right? Cutting and pasting, very simple. Let's see where I put it. Put it down there. So I'm going to grab it there. And I can see that actually that circle is going to be a bit too small, isn't it? So let's go back in. Select that circle, and we'll delete it. And we'll start. Now here's where some of the drafting stuff comes into play. I'm going to do the same circle, but I want that circle to be centered on the midpoint of the axis, right? So when the robot spins, it's spinning exactly on its center. So I'm going to start my circle from the midpoint here, and then just draw it out until it looks to be about what I want to have. So maybe we'll say right about there. And I'm always kind of anal about weird numbers, so I'll just make it like 2.5, say. Okay. So we got that, and we know that it's exactly centered. And then we have to have some support holes, and we'll just pretend like they're 1/4 inch, right? So we'll just make them. You would actually measure out whatever screw or bolt, whatever you're using. So we got one of those there, but we need 4. Okay. So the easiest way I found to do it is we select the one, which we've done, and we want to do a thing called mirroring. Okay. We want to make another copy exactly on the center axis away from this one. So I've selected that one. I select my mirroring tool, which I think is in here. Where's it at? Hang on. Here it is. Here's my mirroring tool. So I select the thing I want to mirror. Then I tell it what axis do I want to mirror on. So I'll go from the center, and I'll just draw a line this way, and it'll mirror it. But that's, it moved it, right? We want to make a copy. So our first step actually is to copy that, then paste it, and then mirror it again. So now we have two. So now we'll select both of them. We'll do that same thing, mirroring. Oh, wait, yeah. Make J. J to the rescue again. All right, so now we've got actually 4 circles here. We can only see 2, right, because we pasted. But now we're going to mirror along this axis. So there we go. So now we can be assured now that all 4 of those circles are exactly the same, and they're equidistant from the center of the robot. And in this robot, that's important because we want it to spin exactly on the center. And you could then do some other things if you wanted to, if you wanted maybe make some cutouts for, I think I have a servo. Let's do open, where's my comment? It's not this one. I've got one that has a servo already. No, it's not that one. I think it's on this one. There we go. So I've already drawn out a Futaba servo. This 303 servo is a very common one. They're like $9. They're very inexpensive. They're not continuous rotation, but they're easily modded for that, say if you had something you wanted to spin. So same deal. I'll just take that. Let's go here again. Copy that. Back to the one we were working on. Edit, paste. So we can see, in this case, that's just barely big enough to put that there. So now you may think, well, how am I going to line that up? I mean, you can do it by eyeball, pretty close. But once again, here's where these drafting features come in. Let's zoom in a little bit. Whenever I get close to something, like the midpoint, or the center of that circle, see how it says center? Center? Midpoint? So I know I'm on the exact center of that little chunk of drawing. So I can take that, come up here and just touch that center there, and then as I come down, see, it's giving me, so I know I'm on that center line. So we'll put it right about, oops, we'll put it right about there. Where this also comes in handy is, if I want to draw a line at 45 degrees from the center of this circle, I just start drawing the line, see, and it says 45. It gives you the common ones, like there's 90, there's 45, it'll snap to it, like that. Or I could say, no, I don't want 135 degrees, I want 156 degrees. It'll change the angle, so you can do that very easily. So like I said, it's kind of a mixture between CAD and drafting, and I like it a lot. It's a really good program. So let's take that line out. Let's move on to the next step. So we have our piece there. We ended up with a little stray bit of tire tread there, so we're going to take that out.
Is it freeware?
No, actually, this one is it's about $40. But I tried all the free ones. I tried, a couple. I tried a TurboCAD, QCAD. I mean, there's 20 or 30 different ones you can try, and I tried them all. And I tried to do the exact same thing in each one, and then found which one was the easiest to use, and then I ended up with this one. So, this is definitely one. But everybody has a preference. TurboCAD has a lot of TurboCAD and AutoCAD have the capability to do like text commands. So, like Jerry, remember Jerry that moved to Texas? He did almost all of his CAD with text commands. He would say, like circle, space, 10 space. He would give all the, and then would create the circle. Well, I'm not going to do that. I'm going to use my mouse, right? So all right. So we got that thing there. We need to get this pretty close to the edges of our quadrant. We'll just say right about there. And that becomes important if you're trying to use the wood efficiently. Like I could put it right smack in the middle of my piece of wood, but then I've wasted the piece of wood. I've cut one thing, right? So if you get close to those edges, you can then put multiple things on there and then use your wood more efficiently.